Okay, so now we are left with some of bitwise operator, and we are doing for positive integers. So as you know already that only these bitwise operators work on integer or long data type. Now let us see some of you which have been left. Now, okay, logical complement operator, shift operator. Let us start with shift operator. Now here one example is given. Suppose x is an integer and we want to left shift left shift 4 times. That means how do you write x smaller than character 2 times and then 4 then semicolon. So that means x, the value will be shifted 4 times. Shifted to what? On the left side. So already you know most significant bit, least significant bit. Now if suppose data is given in 32-bit format or in binary format, so that will be shifted to left. So whenever shifted to left, 0 is appending to the rightmost part. Okay, so suppose value is 1010. Okay, so whenever I have shifted to left, then 0 will be appended at the end. So in the next step, at y is equal to 2, we can see 0 has been appended. So what will be the new value? New value will be 20. So that means each time I am shifting the bit to the left, I am multiplying with 2. Okay, that is the value when I will apply the shift operator. Each time I will apply shift operator one time, so the value will be multiplied with 2. Okay, if value is 10, then the new value will be 20. Once again I will shift, then new value will be 40. If once again I will shift left, then it will new value will be 80. Okay. Now let us go into further details. Okay. Yes, fine. So now left shift. So smaller than character. So you have to write 2 times. So suppose my x value is 10. This is my integer value. Int x value is equal to 10. Symbol. Okay. Now I want to shift with how many times? 1 time. So how can I write? X left shift operator 1. So this is a binary operator. So this operator is a binary operator. Since this applies on 2 operands, one is x, another is 1. That means I want to shift this x value, whatever the value stored in x, 1 time to the left. If I write x left shift 2, okay, whatever the value stored in x, I want to shift not exactly that value, the binary value of the integer stored in x. That means 10. What is the binary representation of 10? That is 1010. Okay, so I want to left shift to left 2 times. Okay, let us see what the result is coming. So as you know, so all integer can be written in 32-bit. Okay, 32-bit format. Now I will start from the most significant bit. Suppose this is my 32-bit. 0 0. Since my value is 1 0 10, so in binary representation I can write 1 0 1 0. Rest all value will be 0. So all 28 bits are 0, and this last 4 bits will be 1 0 1 0. Now I want to shift 1 time. So whenever I shift, so this 0 value, so now you think like this box, all bits are stored in the box. Okay, so there are 32 such box. Okay, so this last the most significant bit MSB side, okay, or at the 32th bit, so this will be moved here on the left side and this will be discarded, and all bit will be shifted like this. So this bit will be shifted to this bit will be shifted to this, and this bit will be shifted to this. So what will the new value? Now let us look at this. 0 will be shifted to this, 1 will be shifted to this, and this 0 will be shifted to this, and 1 will be shifted to this, and this 0 will be shifted to the previous value. So after shifting this one, so last box will be remain empty. So what we fill? We fill with 0. That's why we paired with 0. Fill or paired with 0. Okay, now with 0 value at the rightmost. This is rightmost part. So what will the new value? 1 0, all are shifted to left, 1 0 1 0, and 1 rightmost, there will be another 0, and rest are 0. All 27 bits are 0. Now if you converted 2 into integer, then this value will be how much? 20. Okay, this is 1, this is 2, this is 4, this is 8, and this is 16, 32, and similarly like this. So 16 plus 4, that will be 20. Rest are 0. So this value we convert to integer, this value will become 20. Now once again you shift left, shift left. So what will be the new value? 1 0 1 0 0, another 0. Okay, now if you convert 2 into and rest are 0. So this is 32-bit format of this new value, which has been shifted one more time. This is one first time, this is second time. What will be the value? The value will be calculated. This will be 40. Okay, this is 1, this is 2, this is 4, this is 8, this is 16, this is 32. So 32 plus 8, rest are 0, 32 plus 8 is 40. Okay, so now you can see each time I am shifting left, how many times, number of times I am shifting, those many number of times I have to multiply 2. So now imagine I have given the value as x left shift 3 times, x left shift 3. That means I have to shift 3 times. 3 times means what? Each time I am multiplying with 2. 2 into 2 into 2. Whatever the value is there, x into 2 into 2. So what is the value? 2 to the power 3. Okay, x into 2 to the power 3. That is x into 8. Okay. Now if I generalize this term, if I shifted x left shift n times, what is the new value? X into 2 to the power n. This is my new value. Okay, so logically on the background we convert into binary, any 32-bit or 16-bit format, then you shift, then you apply converting to integer, then the exact result will come. So we have already checked this value. Now you can directly, if you question ask x left shift n, what will be the new value? You put forward a simple formula. This is x into 2 to the n. Okay, similarly we will see about right shift. Okay, Let us see about right shift. Okay, this is my formula for left shift. Now what will be the value for right shift? Now suppose x value is same 10. Okay. 10. So I will convert this 0 0 0 0 dot dot dot, final value 1 0 1 0. I want to right shift. Okay, so what will be the value? Right, this is left. I want to right shift, so how can I write? X capital mark double capital mark, X right shift one time. Let us see one time what will see. So all the bit will be moved towards the right side. So this 0 will be first jump to right, and since there is nothing, you simply discard it. So imagine like you have stored in this box. There is a box and this is the box. So 0 will be discarded, then new value will be 1 0 1 and other bit will be 0. Now on the rightmost side, which value will be pushed? Whatever the bit, this is the signed bit, already I mentioned signed bit. This bit will be filled the leftmost part. This thing you remember. Okay, so 0 will be put earlier there, so 0 will be put here. So the new value will be, what is the new value? 1 2 4 4 plus 1 is equal to 5. Okay, so what is the new value? So you can now, each time I am right shifting this value to right, so I am dividing by 2. So 10 divided by 2 is equal to 5. Now let us see one more time I have right shifted to right. Okay, so the new value will be 0 0 all 0 because sign bit is 0. So the most the least yes, MSB will be 0, most significant bit will be 0, the leftmost bit will be 0 and then 1 0. Finally then this one will be discarded. Okay, so final value will be 0 1 0. So what is the value? That is 2. Okay, so new value is 2. So 5 divided by 2, what is the value? That is 2. Okay, 2.5, but the both are integers, this fraction part will be discarded, only integer part will be there, so that will be 2. Okay, so now we can generalize the term. If I am right shifting that many times, x right shift n times. What do you mean by n times? X divided by 2 one time, then once again divided by 2, that means x2 divided by 2, then once again divided by 2 till n times. So new value will be x divided by 2 to the power n. Whatever the integer value will come, so this is the value. So no need to do, you only know the logic, but you can directly tell. Okay, so what is the new value? How many number of times I have divided that x divided by 2 to the n. So this is our new value. So this is a new integer value. Okay, so this is about left shift, right shift of signed bit. Okay, signed bit. Left and left shift and right shift. Now there is another term called as unsigned Okay, so in this sign bit there is also negative integer also there. So we will see what will the value. That will be the same value, but you can put the sign, negative sign, same value. If you left shift 2 times, then that will be multiplied by 2. So x into 2 to the n. If it is negative, then that will be negative x into 2 to the n. If you right shift, then divide by 2. So that will be negative x by 2 to the n. So we will see one with example. Then we will come to know what is the value. Now there is unsigned right shift and left shift. Unsigned right shift and left shift. So unsigned left shift is nothing but this is a special case. Okay, so you can see this unsigned left shift. So there is no nothing to do with signed bit. Okay, so now why this is called left shift? If it left shift, the left shift will be same as this is triple sign, and the right shift will be triple greater than sign. So this is unsigned right shift, this is unsigned left shift. Left unsigned, this is unsigned right. In one particular case, I think right shift. Okay, so whenever left shift similar to x divided by 2 to the x into 2 to the n. Nothing new. This is same as assigned bit. But right shift. So you know the leftmost bit or the MSB bit. Whatever the value, the same with divided by 2 whenever we are doing right shift, unsigned right shift. But the most significant value will be paired with 0. Paired with 0 means you put 0 there. Then you find out the new value, that will be the value. Whatever the case. Okay, this is positive integer or negative integer. Right shift will be always paired with or bit with 0. So this is for the right shift. Okay, so new value will be the whatever the value converting into integer. So that value will not come as x to the power 2 to the n. Not this is wrong. Okay, so this will be a random value. Whatever the value to come, it will convert it to integer. You know how to convert a binary number into integer. So compiler will take that and it will show the result. Okay, so whatever the value, positive or negative, we will see this right shift, unsigned right shift. And unsigned left shift is similar to like signed bit left shift. That will be value x into 2 to the n. Okay, so now let us see a few examples. We have seen the concept, this logic part, then we will see. Let us try out some example. So we click create a class. Int x is equal to 10 and system
result. Out. Let us see the output. So output will be, so these are all integer value. Output will be let's x 2 times. Okay. Now output is okay. So this is for left shift operator. This is sign. This is right shift. Greater than mark 2 times. This is left shift 2 times. This is unsigned. And this is unsigned. I think this is not there. Okay, unsigned left bit is not taken. Okay, fine. So this is same, since this unsigned left shift is same as unsigned signed left shift, that's why it is not taken. So you discard this, but unsigned right shift is there. Okay, unsigned this right shift is there. Now let us take the output. Let us check. Yes, let's shift operator. I have a multiply with how many times? 2 times. So 2 into 2, 4. That will be 40. And 10 divided by 4. 2 divided 2. That will be 2. And yes, unsigned right also, since there is no negative value. So for the negative value, negative integer, this right shift operator for unsigned and unsigned will be different. Okay, already seen what will be the logic. Okay, but for left shift for negative, that may be same. That is unsigned and signed bit. Already unsigned left shift is not there. So we can see here unsigned right shift of operator of this value 10, 2 times is equal to 2. Okay, you can take more example. 10 3 times and the value will be 128. 16 into 8, 16 divided by 8, and 16 divided by 8. So this is our shift operator of this integer value. Okay, you can try it for long also. Okay, but you cannot take other value. Double no, double you cannot take. Okay, only int and long. Okay, so int and int. So this is all about shift operator. Okay, one more Bitwise operator also we have covered, and whatever left is unary operator, ESS, that complement operator. Okay, let us understand this thing now. Okay, this is left shift, this is covered. Now let us go to create a new. Okay, okay, so let us see a value is 5 and this new value is coming like this.
Okay. Fine.
Okay, so tilde operator, you will see complement, logical complement operator. Okay, let us see. You can see the row number 1, 2, 3, 4, 5, 6. This one, negation or the complement of a is equal to -6. A value is 5. Okay, but that negation of a will be, or the complement will be 6. Let us see how can we do. Okay, so now a value is 5. So this operator, complement operator, logical complement. So this operator, this is a unary operator, because there is a single operand or one operand, so that's why this is called unary operator. Okay, now let us see the logic. A value is 5, so 5 can represent as 1, 0, 1. All bits are 0, all 929 bits are 0. Okay. What it will do, whenever I apply this operator, it will invert all the bit to another bit. So if 0, then that will be 1. If 1, then that will be 0. So what will be the value? All will be 1, and this is 0, 1 and 0. Now this is our new value.
Now if you look at this, you will see what is this value. You convert it, it will not come as any other value, because this all are 1. Okay, this 1, 0. This will not definitely come as 6 or something. Let us see what is the value. So whenever a binary representation is given like this, you always check the most significant bit, or the last, or 32 bit. I have already told this is sign bit. If it is 0, then it is a positive number. If it is 0 or positive, then we don't have to bother about anything. If it is 1, then there is a problem. If there is a problem, what do you mean by this is 1? That means it is negative. This is a negative number. You close your eyes and you can tell this is a negative number. Now, whenever the negative number is there, you have to convert it to the decimal or the integer format. How can you convert? Okay, so there is a concept which is called 2's complement. Now, what is a 2's complement? Any binary format, binary digit can be represented in the 2's complement or 1's complement. Okay. Why this is called as 2's complement and 1's complement plus 1? 2's complement is 1's complement 1 plus 1. What is 1's complement? 1's complement is nothing but the inversion of all the bits. Simply you convert all the bit, inversion of all the bit. Okay, let us try this with this one. Okay. Now why there are 2 complement form? All these things we will see in later class when you study computer organization. All these things. So already you know in the digital logic there is a 0, particularly for zeros. In mathematical form we can represent it as 0, simple 0, but in binary format or the digital format there is a two format, one is -0, one is +0. So in this regard, so the representation or the binary representation are use different format. Basically we use 2's complement for representing negative number. Okay, so since these are represented 2's complement, whenever you see a negative number, we have to convert it into the value by using 2's complement. Let us use 2's complement. First you convert into 1's complement. If you convert into 1's complement, all bit will be converted into 0. All 1 will be 0. So we will go back once again. Now what will the value? 1 0 1. Okay, we are not worry about the sign. Okay, sign already keep that this will be negative. Okay, now we are only focusing on finding the value. What will the exact value if you convert into if it is represented 2's complement. Okay, what is 2's complement value is this one. So we have to find this value. So 101, this is 1's complement. 1's complement is this number. Now how to find 2's complement? You add only one bit at the end, only one bit, all are 0. All 31 bits are 0. So you convert, then it should represent 110 and all are 0. Now are you getting? Since this is 110, this is 1, this is 2, this is 4, this is 6. So the value is 6, but the sign is minus. So the now this exact value is exact integer value is minus 6. Okay. So this is how to calculate the logical complement of this number or the integer. Okay, now there is a vast logic behind this, so you don't worry about this now. Okay, now you just calculate in this way. Okay, you first convert whatever the value, if it is 5, 10, 11 or whatever the bigger value is 1000, 1 lakh, convert into binary format in 32 bit, then invert all the value. After inverting all the value, if check this sign bit, if it is 0, then you can directly tell the value that is the complement of this value is this one. If it is negative, you have to find 2's complement of this form. Then you will find the value. Then you append the sign, then you will find this. Now you come to know why this is minus 6, as you have seen in the slide. Okay, so this complement family minus 6. Okay, so this is the exact value, but since this is negative number, you have to find it. So now you gradually coming to know that how to represent negative number. Already I have told you always represent negative number in 2's complement form. So what is 2's complement form? How to represent a negative number? All the operator we have seen, left shift, right shift, XOR, and all these things, they can be applied with the negative number also, but we have only seen positive integer only. What if in case of negative number? First of all, you have to see how to check how to represent a negative number. Okay, suppose a is equal to -4. Now we declare int a is equal to -4. Now 4 is in how can you represent in this binary form? Always I have taught the absolute value of 4. The absolute value means positive value of this integer, that is 4. You represent it in binary form, that is 1 0 0. Then rest 29 bits are 0. Okay, dot 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 0, and we have to make 2's complement. Now let us make its 2's complement. First you have to find 1's complement. What is 1's complement? 1's complement is just invert all these bits, 32 bits. So this is 1 1 1 1, all 1. Last
3 bits will be 0 1 1 and rest will be all 1. Okay, total 32 bit. Okay, now this is 1's complement. Now what is 2's complement? We just add one bit only, add the lowest significant bit or the rightmost bit. The rightmost bit you add plus 1. So what will be the new value? That will be 1 0 0 and all bit will be 1. All rest 29 bit will be 1. Okay, what is the value? This is 4. What are the sign bit? -4. Okay, so this way you can represent a integer in a particular 32 bit or 16 bit format. Okay, now you apply all the operator: left shift operator, right shift operator, unsigned right shift operator, and yes, XOR, logical OR, and then this logical complement operator. You just apply, but this will be the format. Okay, in 2's complement you write this and you try it yourself. You will do some example, okay, if time permits, but the logic part you have understood, right? So whatever the number, positive or negative, you can apply all the operators we have discussed so far. Bitwise operator, or this is called logical operator. Okay, so this operator we have already covered. For positive number, you know how to represent a negative integer in 2's complement in binary format. Then also you can apply the same logic, same concept of this operator. Okay, logical or the shift operator, and you find out the value. Okay, so there are obviously shortcut, whatever you seen for left shift and right shift. Okay, and for this OR and XOR and this logical complement, you have to find out. Okay, if in the question this type of question comes, you can apply the shortcut for shift operator, but for this logical operator like AND OR, you have to find out. Okay, now we have to do it very quickly. So this type of question obviously comes. Very straightforward question sometimes, but not frequently. But you should know this concept. Okay, so now we have covered almost all the operator, not all the operator, only logical operator. We are left with relational operator. Yes, relational operator. This is a very important topic: relational operator and assignment operator. And ternary operator. Ternary operator is also important. Okay, for convention or ease of writing the conditional statement, two conditional statements, and obviously relation operators. Relation operators are very important because it will be useful in all the cases. Okay, and okay, you will stop here. We will cover in the whatever the left our thing, that is relation operator, assignment operator, and ternary operator. The next class.